I give you a graph, and we're gonna do this without a function first,
Okay.
just to like build into that. And let's say the graph has this shape. Like that. Okay. And what you're there's what's called a left sum, which we'll start with first. Okay. And I'm gonna do this in a different color to try to emphasize what you're doing. So the I'm going to draw the rectangles, and then I'm going to tell you how I made those rectangles, and maybe it'll make more sense. We shall see. Okay. All right. So we're doing this from we're doing n equals 4 rectangles. The first thing is I have to tell you the number of rectangles.
All right.
That has to be given. You calculate delta x. So delta x is b minus a over n. So a is where you're starting and b is where you're ending.
Okay.
Okay, so those are given as well. So in this case, let's just say that this is 4. Your delta x is 4 minus 0 over 4, which is 1. So delta x is the width of your rectangle. So that like this one of these rectangles right here, it has a width of 1. Does that seem reasonable?
Yeah.
Its height is changing. Do you agree with me that the height it's there, and then the height's there, and then the height's there?
Yes.
Well, it's changing based on the value of this curve. Like wherever it is on the curve. Like here it's 2, here it's 3, here it's 4. So the way you find the area of a rectangle is you multiply the base, which is delta x, which is 1, times the height each time. Some of this should be like review, like hopefully that was covered in class. Okay. So the we're gonna do some of these problems, but like is the underlying like why we're drawing rectangles clear, or is that still not clear?
Are you you're just drawing rectangles to like understand the area of the space like under the curve? Yes. Under the curve? Okay.
Yes. Like if your graph was a rectangle or a line, a straight line, let's say your function was 3, or y equals 3, the rectangles like perfectly equal the area. But most of the time they don't, because there's very few functions that are nice like this. And that's what your instructor, I think, was trying to explain in some ways. Okay.
Gotcha.
Because like what you're used to is, and I'll draw this more generally, is you're used to a curve that looks like this. And then you're approximating the area by finding these rectangles that sort of like some go below it, some go above it. And it's like a reasonable approximation. Like, do you agree that like these rectangles pretty good approximate the area? Okay. And the more, and so the idea is that the more rectangles you have, like the better the approximation is.
But you can't like just like add rectangles. They have to give you the number, don't they?
They have to tell you how many. Yes.
Okay.
Yes. So like a fundamental problem in this is like, I give you have to be given some things. I have to say like, okay, f of x equals x squared plus 3. I have to say a equals 1, b equals 4, and n equals 2. I have to give you all that information. Like all of these things have to be given to do this. Okay. So so from here, you start, you're like, well, what do I do? The first thing is you calculate delta x, b minus a over n. I'm sorry, I gave you a bad b value. Let me change that to 5. So it's 5 minus 1 over 2, which is 4 over 2, which is 2.
Okay.
So then, and this is a step that is not, I don't see instructors doing. So this is like Matthew's stuff. Is you start with A, which is 1, and you actually like go by however much delta x is. So it's 1, 3, and 5. And there's B. Okay, and you'll see why you do this in a moment. So I'm going to redraw this 1, 3, and 5. And I'm going to redraw it one more time, 1, 3, and 5. Okay, so for a left sum, I'm going to change colors here. You use 1 and 3.
Why?
Because you have to start left. So you start with the left 2, because you have to start on the left side. It's because that's by definition. And then why is it 2? Because you only have 2 rectangles.
Okay.
It's a good question to ask. Now, right?
So use 3 and 5.
Yes. Okay. And you'll see the power of why I'm telling you this in a moment. So then for midsum, which I don't know why they bring up already, it's already confusing. Midpoint sum. You need numbers that you don't have. You need the midpoint between these two, which is 2 and 4, and you use those values instead.
Right. Okay.
Okay. So it's actually like 3 problems. So if they ask you for, and they usually do this, part A is the left sum, part B is the right sum, part C is the midsum. Like it's 3 separate problems. There's a lot of work there. Okay. So let's go to the formula for this so you can actually see it worked out. What I'd like to do here is actually just move this stuff down. I don't know if I can get all this down far enough. Yeah, let me not do that. So let's go back to, so our f of x was x squared plus 3. Okay. And I use like L for left sum. Your left sum is delta x times, and then there's this like horrible formula like thing in here. Maybe you saw. Did you see that in class or not?
I don't think so.
Okay. Well, we're gonna kind of cut through that. So the formula that I like is you definitely want delta x, which in this case is 2, and then you evaluate the leftmost endpoint. So the leftmost endpoint was 1, plus the second endpoint, which is 3. Okay. So
Okay.
again,
This is for the midpoint.
No, this is for the left sum, L.
Oh, okay.
We're doing left.
Okay.
So graphically what we're doing is this x squared plus 3, it has kind of this shape. We're getting that rectangle there. Actually, we're going over 2 units. Let me get rid of that one. And then we're getting another rectangle kind of there. And this is delta x, and this is also delta x. So they're both width 2. And then the height here, this height is f of 1. This height is f of 3. So f of 1 literally means to put 1 back into this. It's 1 squared plus 3. That's this part right here, f of 1.
Okay.
And then this one is 3 squared plus 3, which is 12. So whatever, this is 4 and this is 12. So again, not to scale, but this is height 4 and this is height 12.
So the 1 squared, that's the
f of x.
But the 1 comes from where?
Because we said 1 is the left endpoint. We were given that. 5 is the right endpoint. And because we're doing a left sum, we're using 1 and 3.
How did we figure out 3?
Delta x is 2. So you make a jump here. You go, okay, that's +2, that's
Oh, you
plus
do
2.
+2. I see.
Yes, yes. These are all
So
good
then-
questions.
So you took the 1 from there and the 3 from there, and that's that's
Yes.
X, or those
Yes.
are X.
Those are your values you want to try to find. Yes.
Okay. Okay.
Okay, so like the area is 2 times 4 plus 2 times 12. And that gives you the area of these two rectangles on the right here.
Okay.
So I'm trying to give you like the graphical and then the numerical, like how to do this. So it's 2 times 16, which is 32. Okay, so now we're going to do the right sum. The right sum is delta x times this formula, which you can look up later. It's not important. The delta x is still 2, but this time we're doing f of 3 plus f of 5 because 3 and 5 are the right 2 points to use. Okay. Now graphically, and I do think this is important to like, and not to scale, but like this curve looks like this. So you're going, you actually go way out here at 5, hit the graph and you go left 2. And then you go way out here at 3 and you hit the graph and go left 2.
Do they ask you to make the graphs? Like
your instructor might. On the AP, no. But this is important to know whether it's an underestimate or an overestimate.
So if it's right, is it always an overestimate? And if it's left, is it under?
No, it has to do with the concavity of the graph, whether it's increasing or decreasing. And
So
those
this one, can you go through how to draw it again?
Yes.
I'm gonna confuse.
So what's odd is that you start from the right. So you go to you literally start from the rightmost value 5. You go up until you hit
X equals 5.
X equals 5. You hit it and you go left 2 units because that's your delta x.
Okay.
And then you hit it at 3 again. You go left 2 units.
Okay, gotcha.
Now similarly, you started at 1, you go up and hit the graph and you go this way.
Okay.
Okay. Now you're going to get questions that ask you whether it's an overestimate or an underestimate, and you won't be able to draw these. Like you'll have to use some other information. We'll get to that like sometime in the future. Okay. But you can visually see it's an overestimate because the rectangles are too big. I mean, it's like a shirt that's too big or a shirt that's too small, whatever. So now we go back and we find f of 3 and f of 5. We still use the same function here, x squared plus 3. So it's 3 squared plus 3, 3 squared plus 3. I'm sorry, 5 squared plus 3.
Okay.
Your calculator can do some of this with you, but I think you have some non-calculator parts on your exam. So you want to be able to do this on your own. 12 plus 28. So that's 80.
Okay.
And if we compare that to the previous one, which is 32, like, okay, that's, different. Like it's bigger, it's a lot bigger.
Yeah.
Okay. Now the mid here is again, it's this delta x times stuff in here. And again, your delta x is 2, but this time it's f of 2 plus f of 4. Now we'll go back and look why is that? It's because you're kind of your like left and right numbers with the delta x in between. Your midpoint is the midpoint between those values. Right. There is a formula to get it. I don't really like that. But I like to sort of show these in between values. So graphically, again, like this, it's a little weird because it's like, it's probably the first time you've ever seen this. I mean, so you go to 2.
Is this an integral?
Yes, kind of.
Okay.
Kind of, yeah. It's an approximation. And you go left and then you go right. So see how its width is still 2. Delta X is still 2 here,
Yeah.
but it's because you go, left and right the same amount. So sum is like over and sum is under. And then you go to 4 and you do the same thing. You split it like that. And this one's like really hard to figure out whether it's an overestimate or an underestimate at this point. Okay, so again, we go back. It's still x squared plus 3. It's still this one right here. Same thing.
2 squared plus 3 plus 4 squared plus 3.
Yep. And that gives you what, 7 plus 19. So 52. The midpoint is not the average of the left and the right. Although it could appear to be that way. Just be careful. It's not, we got.
So would you have to say if it's a over or underestimate with that one?
No, you probably don't know enough to be able to do that.
Okay.
I'm sorry, this was the right, this was the left. Okay. So we should do another one of these just to like get some practice on it. Is that okay?
Yeah.
All right. Your instructor didn't provide many examples here, so I will make one up. So let's say your function is 16 minus x squared. And sometimes they do it this way, from -2 to 2, and n equals 4. So this time, this is your A and this is your B. And the first thing I want you to do is find delta X for us, please.
Okay. One. Wait. Yes.
Yeah, so it's 2 minus a -2 over 4. It's I guess short the formula, but that's 4 over 4, which gives you 1.
Okay.
So I recommend starting with the left endpoint, and then you go delta X. Now, what's interesting is you always get your n value plus 1 there. So there's 5 points.
Wait, where did you get those 5 points from?
So you take A and you add, see, this is your A value.
Yeah.
That's your left boundary. And then you add 1 to it. You add 1 because that's your delta X. And then you add 1 again. And then you add 1 again. And then you add 1 again. And you stop when you get to the right boundary.
Okay.
Your book will say it's like F plus A plus I delta X, something like that. And that's what we're doing here, but it's not, it's cutting through all of that and like to the actual like mechanics of how you do this. So with your left sum, to show this in red here, this is your left sum. You're going to use those. And then we'll draw the numbers again, -2, -1, 0, 1, and 2. And your right sum is here. Okay, and then your mid sum, ooh, this one's where you get some fractions. So your mid sum is actually none of these values. You got to find the 4 midpoints. So it's -3/2, -1/2.
Did you use fractions?
Yes,
okay.
Absolutely. Yeah, we're decimals, but this one's still doable by hand, as horrible as it seems.
Oh, so it's fine to do decimals?
Yeah. Yeah, but I mean, you can do this one by hand, but like we want to focus on the midpoint, or I'm sorry, on the left and the right sum. So this is your mids.
Okay.
Okay. So we're gonna do the left sum first. I think I made a mistake up here, so let's just, you can just ignore this. If you go back and look at it later, because it's out of order. So the left sum here, we got to get our function. Our function is 16 minus x squared. So our left, go down here. So our function is 16 minus x squared. Our left sum is delta x, okay, which is 1, okay? And then we got to go do f of our leftmost value. So our leftmost value is -2 plus -1 plus 0 plus f of 1. There should only be 4 here because n equals 4, and that means 4 rectangles. Is that okay?
Yeah.
Okay, so now we got to find each of these. So you gotta square the number and subtract it from 16. Square the number and subtract it from 16. Square the number and subtract it from 16. Square the number and subtract it from 16.
Okay.
So you get 30 and then 28, so you get 58, it looks like. Okay.
Okay.
Now your right sum, again, so you're gonna your f of x, 16 minus x squared. You don't have to write this every time, but you gotta remember it's delta x times. Okay, but this time it's 1 times, and then you're starting over here at -1 plus f of 0 plus f of 1 plus f of 2. You could try and start from the right here because that's actually where you are starting. It's 2, 1, 0, and -1, but it's a little odd to start from the right since we go left to right. And that's why I left. Go ahead.
How did you choose those ones again? The -1.
We'll go right back here. So see how the left used the 4 left numbers?
Why
and
is
the
it
right
4 again though?
4
That's the
rectangles.
N? Okay.
Yes, yes.
Gotcha.
And see, there's overlap. The middle ones always overlap, but the end points do not.
I see. Okay.
Okay. So we got to find these values again. So the 15 plus 16 plus 15 plus yeah, 12. So this one's actually the same as the other one.
Right. Okay.
Okay. And for the midsum, it's delta x times, and
Or are you using your the fraction?
Yes, you have to use these midpoints.
So you use all 4.
Yep, f of -3/2 plus f of -1/2 plus f of 1/2 plus f of 3/2. Now, thankfully, because of symmetry, like these are going to be the same. The inner ones and the outer ones are going to be the same.
Yeah.
So it's 16 minus -3/2 squared. So it's
9/4.
Yes. So -9/4. So that gives you a 55/4. And then again, 16 minus -1/2 squared, 64/4 minus 1/4, 63/4.
Yikes.
Yeah, and you can, I mean, it looks bad, but you can actually do all this. And so you get what do you get there? 110 plus 126/4, 236/4. And that actually works out to a nice number, 59.
Okay.
Okay, that just happened to work out. So the key here is being able to like run through like finding delta x. You got to find delta x, b minus a over n. then getting the numbers for the left, the numbers for the right, the midpoint, and then knowing like, okay, I got to evaluate them here in this function. Did any of your math Excels have you do any of this? Because you can also do it with tables. There's other variations on it.
Yeah, I've only done the first one, which was on this unit, and it was like find the left-hand sum or whatever.
Okay.
So
there are a lot of calculators out there also for this. So just keep that in mind. So we should either do a math Excel if you have questions on this, or we can move to one of these using velocity to find distance.
Was that in the
presentation?
Yeah. Let's let's go there, I think.
Okay. All right. Okay. So this is a graph of velocity and time. Okay. So let's say you're going to run a marathon, 5K, maybe. I don't know.
Definitely a 5K.
5K. Okay. And let's assume you can instantaneously get up to speed. Okay. But that's probably not realistic. So what's realistic is you start out and you speed up, and then you kind of maintain that speed and you get to the finish line, something like that. Maybe that's realistic, maybe it's not, but let's just, and we're not even going to assign values to this.
Okay.
Okay, so let's say I wanted you to find the distance from t equals 0 to t equals 6. Okay, so here's what I'm actually asking for. I'm asking for the area under the curve from 0 to 6.
Oh, this is where you have to like do different shapes and stuff under
you can, it. Yeah, you absolutely can here. So like let's say you're into triangles and rectangles, like maybe you visualize that. Okay. You could also visualize this as trapezoid. It's whatever you kind of like see and you do. Okay. So the area, and you can group these, like the area of 1, sorry for using red, but 1 is 1/2 base and then the height. And then the area of 2 is the base.
Times the height.
Yeah, 4 times 2. So we get, all right, so let's say this is, so this gives you whatever it gives you 2, this one gives you 8, and that gives you 10. All right. So is that clear so far?
Yeah.
Okay. Now, let's say kind of the similar scenario here, but it didn't come out very good. All right. So we've done this for you. So you're going here, and then you go here, but then you do this. What does this mean right here? And this is velocity and time again. What does this point mean?
T equals 0.
What is t is 0 is here. What is the velocity value right there? The velocity here is 0, then it's 2, and then it goes back to
0.
So you're running, you're speeding up, and then you're maintaining your speed, and then you stop. Do you agree with that?
Yeah.
So what would this mean if you go down this way? What happens if you have negative velocity?
You're slowing down.
You're doing more than that. You went from moving forward to now you're moving backwards because you have negative velocity.
Okay.
So in this region right here, okay, so this is 2, this is 5, this is 7, this is 9. Okay. from t equals 0 to 7, I want you to find the distance. And so that's all up here.
All right, okay. So 1/2 times 2. 19.
We're talking about this one in here, right? Like this. So this first one is got an area of 2.
Yeah.
Plus 6 plus 2.
I didn't get 6.
So
Isn't
base
3 times
3, 2.
Where did I get it? 3 times 5. Oh, I was probably looking at the 5. Wait.
Okay.
So wait. So it's from 2 to 5 and then time. Okay. So yeah, 6. So then
now, yeah. So now what's going from
from
t? Yes, from t equals 7 to t equals 9. What's going on there? How far does it go?
2.
2, but it's negative.
Because
it's down here on the bottom.
Okay.
So there's your instructor. Sorry, give me 30 seconds here. Okay, so your instructor is trying to, there's really 2 questions they're asking. There's the distance, and then there's the displacement. Do you remember this from physics, or have you talked about this earlier in the course?
I have not taken physics, so not from physics.
Okay.
But no.
Okay, so there's a track. You go around the track. If you start here and you go all the way around, your distance is one like track, however long your track is. Okay, so like if you go all the way around, most tracks are 400 meters. Your displacement, though, if you go all the way around, is 0, because it's relative to where you started. You didn't go anywhere.
Okay.
So like if you start in the morning, your car's in the driveway, you go to school, you come back, your distance is however far you went from school and back.
But you ended up in the same place.
But your displacement is 0.
Gotcha.
Okay, and that's important here, because there's 2 questions that could be asked. One is the distance traveled. So the distance traveled takes in, like, if stuff's above the x-axis, it's positive, and if it's below the x-axis, it's also positive for distance. Displacement, you add and subtract the areas. So like this is 2, this is 6, this is 2, and this is -2. So your distance is 2 plus 6 plus 2 plus 2. But your displacement is 2 plus 6 plus 2 plus -2. Because your negative velocity means you're going backwards.
Mm-hmm.
Okay. Is that I don't know, does that sound okay? Give me some feedback on that if you can.
Yeah, it makes sense. So distance is 10.
Yes.
Right.
The displacement is 10. The distance is 12, because you count negative. Like when you, in your car, when you drive to school, your odometer reading goes up for every mile you travel. It doesn't matter whether you go forwards or backwards.
Oh, okay.
Have you ever seen the movie Ferris Bueller's Day Off?
Yeah.
So they're trying to wind back the odometer at the end because they weren't supposed to take the car out, and you actually can't do that. You can't like make it go in reverse and have it reduce the miles because it still thinks you're moving. It knows that you're moving. So this distance is like your odometer. Your odometer measures.
For why displacement you don't include the -2?
Yeah, because displacement it's just a different like measuring stick. It's like how far am I from where I started?
Okay.
So we gotta just kind of accept like what it is. Because they're gonna ask for both of these.
Okay.
And so the reason like on slide, I don't know what slide it is, but the reason your instructor is only asking for distance is because it's always positive. He's not getting into that yet about what could happen there. Okay, so let's try another example. Let's say v of t equals 10 minus 6t, and we want the distance from 0. I'm sorry, I picked bad numbers here. Let's go from 0 to 2. Okay, so this time we're giving a function, so we could graph it. So here's what the graph of this looks like. That's really, this is t. I should do a better job of that. So let's, these aren't good. 1, 2, 3, 4, 5, 6, and that's 2. So that's 12, and that's 2.
Okay.
So the distance is literally this area right here.
So 1/2 times 12 times 2.
Yes, 1/2 times 12 times 2.
So 12.
Yes. Okay. Now, what is the distance from 2 to 4? Well, this thing keeps going down. 1, 2, 3, 4, 5, 6. We're asking about distance, not displacement. So we just care about how far it went. So what's
2 and -12?
So it because the distance is always positive. It's like your odometer is always positive on your car.
So it doesn't matter that it's -12.
Yes. Okay. Now, so if I ask you the distance from 0 to 4, that's 12 plus 12. If I ask you the displacement from 0 to 4, that's 12 plus -12.
Oh, that's so weird. Okay.
So we got to get comfortable with that idea because you're gonna be asked to do a bunch of these types of problems.
So for the distance from 2 to 4, could you, like when you're writing it down, could I like write 1/2 times 12 or times -12 times 2, and then because but then the final answer would just be positive?
Mhm.
Okay.
Yeah. Now, there's a little bit of like, remember when you were doing the difference quotient early in the course, and then the instructor said, oh, and by the way, here's how you take a derivative without the difference quotient.
Yeah.
There's a little bit of that going on here. It's not quite the same, but there's a little bit of that here. So, but they do tend to ask these graphical questions. So you gotta keep that in mind as well. Okay, so and that's like, I'm looking at your notes here and I don't see that your instructor showed you sort of the more sophisticated way of doing this.
Yeah, I don't think he really did.
Okay, so let's say v of t equals the absolute value of x minus 4. Yeah, and I want t minus 4. And I want the distance from 0 to 2. What do you think you will do to try to figure that out on this one? So what does the graph look like?
Like the V shape.
Okay, it's a V and it hits at 4.
With pause up 4. Right?
Yeah, so it get this, let me get that. So it looks something like this. Boom, and then it goes up forever. So from 0 to 2 though, we want this. So how are you going to find that area? Are you going to draw a square and a rectangle, or are you going to use a trapezoid? Are you going to find the area of the big triangle and subtract out the little triangle? What's your kind of your?
Wait, so could you do like a square up to the like middle there, and then do a little triangle on top?
Yes.
Okay, that's what I'll do because I don't know that trapezoid formula. Okay, so it would be 1/2 of times 2 times 2, so 2, and then 2 plus 4, 6.
Yes, 6. Okay. So now if I wanted you to go from t equals 0 to t equals 6, I'm sorry, 4. So that's this whole big triangle.
Okay, so you can just do 1/2 times 4 times 4. That's 16, half 8.
Yes.
Okay.
All right, so now what if I want to know, this is like the last one, t equals 0 to, I don't know, 7. See how you'd have to draw this other triangle here and add it to it.
So you have to do 1/2 of 4. So do you start it at 4, so 3. So 1/2, 12, 6 also.
So it's 3 and 3. So it's 1/2 of those base times heights. That's
it's 3, not 4. I see.
Yeah.
So it's 9. Wait.
9 halves.
Yeah. So or 4.5. Okay.
It's 8 plus 4.5.
The height changes. That's the
Yes.
difference. Okay.
Okay. So let's do another one here. I'll just draw the graph. I won't make you graph it. It could very well, cross over. So it could look like this. Sorry, that's really poorly drawn. Like that. And again, like reasonably, it could ask you, like, part A is t equals 0 to t equals 2. And that's this first rectangle here, right? So that's 2. B though could ask, like, well, what's 2 to 6? And that's this down here, which ends up being 4. Okay, but the real question is, well, what is it from t equals 0 to t equals 4? Okay, and that's where you got to be careful. Like, is it asking for the distance or the displacement?
Well, how do you know?
It has to tell you.
Oh.
It has to tell you. So the distance from 0 to 4. Okay.
6. No.
It's 4. Distance is 4, but the displacement is 0, because let me see if I can grab. I'll just redraw it.
I thought the distance was the 2 added together, though, the 2 and the 4.
So the graph here This is an area of 2. This has an area of 2. So the distance is 2 plus 2. The displacement is 2 plus -2.
So where do you get the 4 from in part B? Or no, not the 4, the oh, I see, because it's half of that.
Yeah.
Oh. And then the displacement. Okay. Because it's -2 on the
Yeah,
bottom.
yeah. So kind of final thing that you might see here is they might give you something that looks like this. They tell you this is a circle with radius equal to 3. It's actually a quarter circle. So you got to remember your area of a circle.
Pi r squared 8.
But since it's a quarter circle, you divide by 4. So that's
Wait,
pi.
Pi r squared h, or what is that for?
It's a quarter circle. So you take a quarter of this. This is a quarter of the whole thing.
But what is pi r squared h for?
This is a 4.
No, I know, but like, what is that for?
Oh, I'm sorry. Pi r squared h is for a cylinder.
Oh, okay.
I'm sorry, I didn't follow you. So this is 9 pi over 4.
Okay.
So they could give you
Would they
something.
ask you for the displacement or something?
Yeah, they could say, what's the distance from 0 to 3? And it's 9 pi over 4.
Okay.
But they can mix and match your geometric shapes.
Right. Okay.
All right. That does take us to the end of the lesson for today.
Okay.
So thanks so much for scheduling. I hope this was helpful.
Thank you.
And I will send you the notes here shortly. I'll remind you next time to turn on your screen recording if you want that lesson right away. It still takes a little time to upload.
Oh yeah, it's fine right now because I don't have a test or anything coming up.
All right. Well, thank you again, and have a great night. Bye now.
Thanks.